Okay, so in the last class, we were discussing about uh, how to draw very basic graphics using Python, and we used a particular package called as Turtle. So before we move on to this video, let's quickly go into what Turtle is, just revise to what is Turtle is before we can move on to the further topics. Okay, so you import or you create a Turtle object whenever you want to make use of Turtle. You create a Turtle object from the package called as Turtle. So from the package called Turtle, we can import a class called Turtle. Okay. Once you have imported this class called Turtle, I can create an object of this Turtle class by calling its constructor Turtle. Okay. Now T is an object of a Turtle class. You can see as soon as I've created an object, a new screen has been created. That is basically, which is nothing but the Turtle. By default, it creates a window, a canvas, and a window. And this particular arrow that you see is nothing but the Turtle, which we're going to make use to draw a line. Okay, so there are various functions. We already discussed various functions. For example, one of the functions is if you want to like move forward with this turtle. Okay, so T is the object which I have created. So T dot forward is the function. Okay, forward, and you provide how much pixels forward you want to move that with. Say I say 100 pixels, then the turtle will move 100 pixels. As it moves, it will also draw a line. Okay, we already saw that. The reason because why it drew a line is because it was able to because the turtle's pen is currently it's in down position. So I can check what is the position of my pen, or basically what is the status of my pen. If I call a function called t dot is down. Okay, this returns true, so that means my pen is actually down. Now to lift a pen up, I again call a function t dot uh, up. Okay, t dot up would lift my pen up. Now again, if I go t dot is down, I will get the value as false. Okay, so if my pen is up, and then if I move forward again, if you look at, please look into this particular window. So I'll just resize this. Okay, so if I move the turtle again, t dot forward, and say this time 50 pixels forward, 105, 50 pixels forward. Okay, you can see it move it the turtle actually moves 50 pixels forward, but it's not drawing a line. So wherever you want to draw a line, different shapes, or you can use this turtle to move forward and with a pen down. Now to rotate to draw in different directions, again you can turn your turtle to the left or right. Currently, the direction of my turtle is can be retrieved by calling the function called t dot heading. Okay, heading to which direction? So currently it is heading to 0, 0.0. So the whole canvas that we have over here is actually a Cartesian coordinates where the origin is the center of the screen. Okay, and 0, 0.0 heading at 0, 0.0 means it's going around the x-axis, the positive x-axis. Okay, so now if I want to go into the positive y-axis, I need to what? Turn the turtle should turn left to what? To a 90 degrees, right? So to do that, I'll say t dot left of 90. Okay, you can see that my turtle has turned 90 degrees. Now it's facing towards the knot. Okay, it's facing towards the knot. Now if I move forward again, the same thing, there's t dot forward and say 100. Okay, you can see the turtle is moving upwards. It's not drawing a line because currently my is down. The pen is not down. It is up, so it will not draw a line. Okay. Now we also saw a function in the last class to draw a square. Let me just open that. Yeah. So we have this particular function which we already done it in the last class. This is a function to actually draw a square. So to draw a square, you need the total object, the first thing, x and y, okay, to the position where you want to start drawing your square, okay, and the size of each side, or you can say the size of my square which I want to create. Okay, so the first thing that I've done is I've set t dot up. That means I need to first go to this particular position where I need to draw the squares. So while going to this position x given by the x coordinate x and y coordinate y, if the turtle draws a line, then it will just draw some line or a random line in between. So to make sure that line does not come while going to this particular position, what we do, we actually put the pen up or lift the pen up first. So to lift the pen up, t dot up. Okay, I move to the particular location where I need to start drawing the square. Okay, by calling a function called go to. Okay, there are many functions. You can look into all these functions in your textbook. Okay, so one of those functions go to move to a particular location within your canvas, given the x and the y coordinates. Okay, and after going to that particular position, I have set the heading to 270. 270 is nothing but towards south or towards downwards. That is, I'll have this particular arrow moving downwards. 270 is downwards. Okay. So I've set it downwards. So the only reason I set it downwards is I want to start in the top left corner of my square. When I'm drawing the square, I want to start. I can use anything. I think I can provide this as 0 if I want to. That means it will start at the bottom left corner of my square. Okay, so this is not that important. This particular statement is that not that important. It's just where to start drawing a square. From which corner do you want to start drawing a square? Okay, so in this particular case, I have set the value as 270 so that it will to start drawing the square from the top corner. Okay, next I need to start drawing my square. To start my drawing my square, I have to make sure that I put my pen down. Okay, the turtle's pen down. So I call t dot down. Okay, and what I have square is basically 4 straight lines. Okay, so I just need to move forward. Okay, you can see over here in this line, I move forward for 100 pixels to the forward, and then I have to turn 90 degrees, move 100 pixels again, turn another 90 degrees, move 100 pixels, turn another 90 degrees, and move 100 pixels. So basically, these two statements, that is the how much you need to move forward given by the side, the size of the side, okay, and how much you need to turn. So since it's a square, I'll turn 90 degrees. Now, if it is some other square, like some other shape, such as an hexagon or a triangle or something else, you need to change this particular degree. Because it's a square, we know that all the angles in a square are 90 degrees. So it turns 90 degrees, draws a line, and move forward. And we know because these two statements are repeating exactly 4 times, I'm putting it inside a loop, or in this case, a for loop, ranging from 0 to 3. So when s is equal to 0, it will draw a line. Okay, so move forward, draw a line, turn left. Again, s is equal to 1, it'll draw a line again, turn left. S is equal to 2, draw a line again, turn left. Okay, so let's just run this program. Okay, so I defined a function and an object. I have not called a particular function. So let me just take this. Yeah. Okay, so let's call the function. The function is draw square. Okay, draw square, which takes in 3 parameters. One is t. T is already been created. Okay, x is the location where I want to start drawing a square. Say the location is say at say 20. Okay, and y location say again 50. Okay, some random location, and say the side of the side of the square should be say 100 or 50. Again, 50 pixels in size. Okay, and now let's see that. Okay, so if I call this particular function, you can see it draws a square for me. Okay, it turns 90 degrees, moves forward for 50 pixels, turns 90 degrees, moves forward for 30 pixels, and it does it for 4 times and creates a square for me. Okay, so once more, let's give a different location. Let's give, say, minus 100. That means it goes right to the left. Okay, so x-axis, y as, say, 200. So your square, the square will be somewhere in the top of your, okay. And say I want to create a larger square, say with size 150. Okay. So you can see over here, I created a square with size 150. Okay. So this is how you draw a square. Okay. Now let's move. Okay. So yeah. Now next, the same thing. Let's take the same code over here. Let's define one more function. This time, let's write a function to actually draw a different shape. Okay, let's consider a hexagon. Okay, suppose we want to draw a hexagon. So what can we do? Again, def hex. Okay, and this time I can get the x and y coordinates. Okay, where I want to specifically draw my hexagon. Let's not do that. Let I draw the hexagon wherever my turtle currently is. So if I want to draw it in a particular position, I need to make sure that I move my turtle to that particular position before I start drawing. Okay, so this time I'm going to write a function to draw an hexagon at the position where the turtle currently is at. Okay, so over here, I need my turtle object to draw it. Then the length of the sides of my uh, hexagon, okay, which I'm going to draw. So next, over here again, hexagon. How many sides? Hexagon has 6 sides. So the same thing as before. So I need to repeat the same code for, say, for each side in range 6 sides, right? So say range of 6. Now, sorry, I missed out. Yeah. Okay. Now, next thing, start drawing the first side. Okay, to draw the first side, t dot forward. Okay, of the size of my hexagon. Let's say it's given through the function called, so length, size of the length. Okay, size of one of the sides. So I've drawn one side. Next side I have to draw. I need to make sure I have to turn how many degrees. So how many? When I have 6 sides, a hexagon I have to turn, say, 60 degrees. Okay, so this is basically the angle between two sides between a hexagon is 120. So if it is 120, then I have to turn only 60 degrees. So t dot. So over here, say I want to turn left. I am drawing the hexagon towards the left. If you turn to the right also, no issues with that. Both are right. So over here, I'm going to turn towards the left, and it's 60 degrees. The reason is, if I have an hexagon, the angle between two sides or a particular corner in the hexagon is 120 degrees. And to make sure that I draw a line in 120 degrees, I just have to turn 60 degrees. Total is 180 degrees. A single line is 180 degrees. From 180 degrees, I just have to turn 60 degrees so that I create an angle of 120 degrees. Okay, so this is a function to draw an hexagon. Okay, let's save this once more and run. Okay, again the same thing. Yeah, so this time I'm going to call the function call as draw. What's the function defined? No, hex, not draw, hex. Okay, so I call the function called hex of I pass the turtle object. I have my turtle over here and a length. Okay, so let's say I want to draw a hexagon of size 100. Okay, so it will start drawing at a position where the turtle currently is at. Okay, so once I give this, if I run this, you can see it draws an hexagon for me. Okay, I hope you are all clear regarding this. Okay, now let's take this one step further to create a very interesting design. I think Adil has already shared certain designs that is already done in the group for the Onam പൂക്കളമൊക്കെ വരയ്ക്കാൻ വേണ്ടിയൊക്കെ യൂസ് ചെയ്യാൻ വേണ്ടി some code is given there. You can always look into that. That is really good, which I saw. The same thing, if I want to create some designs like this, I can have multiple such hexagons. Put this whole thing, this whole function call into another loop and make sure every time I draw my hexagon, I turn a little to the left. The original position, from the original position, I turn a little to the left. So in that case, what can I do? Let's draw some patterns like that. So the same code, let's define another function. Okay. Okay, let's define another function. Let's call it uh, define pattern. Okay, draw a pattern using hexagons. Okay, so I have T, my total object, then number of hexagons to draw to create a pattern, that is n, and the size of the hexagon, which is the same thing earlier, length. Size of all the hexagons with the same size. Okay, so what I'm going to do here is again going to define a function to create a pattern using hexagons itself. So every time I start drawing a hexagon, you can see over here in this case, I started drawing a hexagon, I drew a hexagon, came back over here. Next time, I'm going to turn this turtle a little towards the left or right, whichever direction that you want to. In this case, I'm going to turn a little towards the left and draw a hexagon again. Again, after drawing it, I'm going to again turn this a little more towards the left, draw a hexagon again. It goes on until I draw enough number of hexagons to complete a complete circle. Okay, so to do that, so a circle is 360 degrees, and if I say as an input, if I need say 6 hexagons to draw, I need to draw 6 hexagons and create a pattern like that. So what I have to do, 360 divided by 6. So how much I should turn, how much degree should I turn to draw the next hexagon? So first at 0 degree, I drew a hexagon. Then if it is just 4 hexagons, then at 90 degrees, I'll draw another hexagon. At 180 degrees, I'll draw another hexagon. At 270, I'll draw another hexagon. So it divides the 360 into 4 and what draws an hexagon. So based on the number of hexagons you want to draw, okay, you need to turn left so that it completes a complete pattern. Okay, so to do that again for the n, or so for count in range of your n, so the number of hexagons that I have to draw. So if there is 10 hexagons I have to draw, then for each hexagon I need to call the hexagon function. So hex of your again t comma, which is a function, and length, t and length. I am calling the same function to draw the hexagon. Okay, so t comma length, 3 comma length. Okay, and next, after this, after drawing the whole hexagon, as I've told you earlier, I need to turn my turtle a little towards the left or right. Okay, how much towards the left or right is defined by the number of hexagons that you need to draw. So again, t dot turn left. After drawing the hexagon, I'll turn left. How much? The total, I have 360 degrees since I want one complete round. But how much ever number of hexagons I have, I need to draw a complete round so that I can create a good pattern. Okay, so 360 divided by the number of hexagons that we have. So it will equally divide 360 into the number of hexagons. For each hexagon, it will turn equal number of degrees towards the left and draw a hexagon. Okay, so that is how this pattern is created. Okay, so if I save this and run this once more, okay, let's call the function called pattern this time. called a pattern with T, and say I want to create 10 hexagons with length 100. So what happens? 360 divided by 10 is basically 36. So every 36 degrees, after drawing a hexagon, it will turn 36 degrees, and again draw another hexagon. It will turn again another 36 degrees, and this will repeat for 10 times since I have 10 different hexagons to be drawn over. So if I look at this, the output of this, the first hexagon, you can see it turned 36 degrees. It's turning like that and keeps on drawing the hexagons, and this creates a very good looking pattern. Okay, next we'll just look into one more function in this, and then we'll do some exercises. So there is one more thing, like the hexagons that we have drawn currently has what? It's just drawing. Like we can also fill colors, or we can say that we can use a particular pen color. For example, by default, the pen color is always black. Now, if I want to say that the pen color to be something else, okay, to use something else, some other pen color, in that case, what I can do is, yeah, so say T dot pen color. Let's run this once more, 1 minute. Because I think it's not actually running. So F5, yeah. So T dot pen color of, say, let's make it red. Okay, so you can just provide a string, or you can provide any hexadecimal value using the hash sign. For example, you can say, let's first look at red. Say I said T dot pen color is red, and then I'm drawing the pattern. Okay, so Control C, V, and okay. So let's draw the pattern. Now the pen color is red. You can see the turtle itself, the border color has become red. And now if I press on enter, I'll draw the hexagons in red in color. The same thing, the whole shape can be filled with a particular color called as fill shape. Okay, the whole shape also, other than the pen color, the whole shape can be filled with another color. Okay, so to do that, let's change this code a little bit. Say for each hexagon that I'm drawing over here, okay, for each hexagon that I'm drawing over here, I want to have a different fill color. Okay, take a random value. So let's have first a list of colors. So colors is equal to, let's create a list. Say I have red, red, yellow, green. I can also have some hexadecimal values, say hash, and provide hexadecimal, say FF23, some random values. Okay, 99. I have no idea what this color is. Comma, let's take some random hexadecimal values. Hash 0, 1, 2, F. So it's always a 6 to go. That is, this represents red, green, and blue. Okay, so let's have some random colors like this. Since we have 10, let's have one more color. So red, blue. Let's have blue also. Blue also. Okay. So I have a list of random colors, and for each hexagon I'm going to draw, I need to make sure that I draw a hexagon filled with a particular color. That is, you can see over here. Over here, the border color, I only changed the border color by setting the pen color, but within the hexagon, I want to change the color of the hexagon. Okay, to do that, I have a function called as, so before I draw the hexagon, I need to set the fill color. Okay, to set the fill color, T dot fill color, and you provide a color over here. If you want to be red, you provide it as red. Okay, you provide result. And if you want it to be green, you provide. But over here, what I'm required is for each hexagon, I need a different color, and I need to randomly pick a color from this list. Okay, for that, I can import a function called random. Okay, I think I already know. Let's import a package called random. Okay, so from the random package, I'm going to say random dot a function called as choice. CHOICE. Okay, choice of from where should I choose my colors? I should choose my colors from the list called colors. Okay, so this will choose a random color from this list and it will set a fill color. Now, if you set a fill color, it will not actually set. Now you need to set when to start the coloring using the fill color. Okay, so you need to say that t dot begin begin fill. Okay, begin fill. Only then it will start using this particular fill color, or else it will not start. Okay. So after I begin fill with this particular color, after drawing my hexagon, I need to stop it. So T dot after drawing my hexagon will be T dot um, end fill. Okay. So let's now run this. Okay, and let's draw the same pattern, but this time I hope each hexagon is colored with a different color. Okay, so when I run this, you can see after drawing the hexagon, for some reason its random colors have been taken. So for first time it's two greens, blue, red, and this is the random color I think that I've given, yellow. Yeah, okay, so random colors was generated and generated a pattern. So when to actually start filling the color is provided by the code begin. So you set the fill color, but that doesn't mean that it would fill the color. It will only start filling the color of a particular shape until you call the begin fill, and that will keep on filling until you call the end fill. Okay, whatever shape you are drawing. Okay, or whatever lines you are drawing, it will begin fill as soon as you call the begin fill, and it will only end at the when you call the end fill. You select the color using fill color. Fill color is only used to select your color. Okay. Okay. So the next thing that we're going to look into is let's use the interactive terminal itself is to manipulate with this particular screen that we have, the turtle screen that we have. Okay. So you can change the background color, the size of the screen, window width, the window height of the screen, and all those things. Okay. All that can be done using the screen property of method. So T dot screen object. Okay, it's actually the screen. Screen T dot screen will display the actually the screen object of my turtle. Okay, now using T dot screen, so I can say T dot screen. Okay, dot I can change the background colors, which is nothing but BG color. Okay, say I want to change the background color to say orange. You can see over here the background color has changed to orange. Same way, if I want to get the height and width of the screen, okay, I can call the function called as uh, p dot screen dot. Okay, just 1 minute. It's window height or window width. I just want to make sure it's visible to you. Okay, screen dot window underscore width. Okay, what is the width of the window? Okay, it's 756. And what if I reduce the width? and run the same code again. Manually reduces, you can see the width is changed. So at any point of time, you can get a width of my window, okay, by calling the function called window width. The same thing goes with, you can get the height of your window by calling a function window dot height. Okay, so this returns the height of the. Okay, now to change, now this will retrieve your height and window. To change the height and the width of the window programmatically, again you can do t dot screen screen dot. There's a function called as setup. Okay, setup. Okay, and you say the setup is width. For width, I say 700 and height also 700. Okay, it actually changed, but it just actually went to a different. You can see it changed to here. Okay, let's do this once more. Control C. Okay, let's print this and see whether it has changed. Actually, it has gone to those with the 700, and the height also is 700. Just to verify it has changed, because by looking at the screen, we don't feel that it has changed much, but when printing out it, we know that it has changed now. Okay, so you can change the window size like that. Okay, so that's it with Turtle and drawing shapes with Turtle. Okay, now as an exercise, what you can do is try to draw a star. Okay, a star using Turtle and fill it with a particular shape. If possible, try to draw multiple stars in a straight line with a small gap in between. Okay. This will be one of the assignments which you need to upload it into your GitHub repository. Okay. So that's it for this video. We will continue in the next video where we will discuss certain image processing techniques. Okay. Thank you.